Hello everyone, welcome to GTC 2021 and welcome to our webinar. Today our topic is about Edge AI Vision. It's about an excited total solution created by Oracle, Radus, and Advantech, a joint force outdoor Edge AI Vision to predict, protect, and inspect in extreme environments. The presenters are from the three companies, respectively. Nick Lim, myself, is a product engineer at Advantech. Advantech is the largest company in industrial computers worldwide. Sudi Sankavaram, Chief Information Officer from Radus Technology Solutions. Radus is a software provider focused on artificial intelligence. The third presenter, Jeff Melrose, who is a consulting sales director at Oracle. Oracle puts all the pieces together and introduces the solutions to the market. This is the agenda of this webinar. We start from why AI video analytics is needed, which is the ultimate motivation of providing an AI vision solution. More and more AI solutions are deployed at the edge nowadays instead of being deployed on the cloud. What are the reasons behind the trend of moving from cloud to edge computing? And what are the challenges we are facing when deploying edge AI in outdoor environments? We will share our thoughts with you on these topics. Next, Sudi will give you a brief introduction of the core of this edge AI solution, the Cobra Vision software created by Radus. Cobra Vision is an advanced AI vision software to ensure safety of all participants involved in outdoor environments. For example, construction sites. Following Sudi, I will talk about another important portion in this solution, which is hardware. Advantech has a wide product offerings based on NVIDIA JSON platforms for edge AI applications. Jeff from Oracle will give you a higher level view of the overall solution, which includes Radus software, Advantech hardware, and Oracle cloud services. The last will be the key takeaways of this webinar. Why AI video analytics? Most simple explained, it is computers watching cameras watching people. Basically, instead of relying on a guard to watch one of these split-screen monitors showing many little images from the cameras, which switch out every few seconds to images from other cameras, video analytics utilizes computer software that can recognize the human form and the vehicles. The computer watches all cameras without even blinking an eye, 24/7. It has vastly more accuracy than a human. And look at this. This is a typical picture to show how the AI video analytics works. Object recognition is a basic function. AI software can recognize human or vehicle, bicycle or bag from a live video. Another example will be behavioral analytics. I have seen an example from internet. In that example, the AI software is very intelligent because rules can be set for the behavior of humans and vehicles. When a computer sees a rule broken, it immediately alerts the central monitoring officer, who then takes over looking at what is happening and acts on it. The analytics software places red rectangles around the suspects and automatically follows them in high definition, and it zooms in digitally. While in another part of the screen, preserving the whole view of the scene. The monitoring officer can then talk directly to the rule brokers over a loudspeaker and tell them to leave the property. The officer can also call the police and guide them directly to the perpetrator. So, instead of just recording events, video analytics actually prevents crimes from happening. It can also be used in parking structures. The AI analytics software can find the parking spots available in the parking structure and works with the system to direct drivers to those available spots, and much, much more. There's no limitation for humans' imagination, and there's no limitation on AI analytics too. There will be more use case scenarios being developed with AI video analytics. Moving from cloud to the edge is a trend. We see a lot of devices for edge computing being introduced to the market. What are the reasons behind this trend? This is the traditional AI infrastructure by leveraging cloud computing. The end devices are connected directly to the cloud and sending data to the cloud for analysis. The end devices will then receive results and will respond based on the received results. This has been a great idea by offloading the work required from the end devices. However, by solving an issue, we have created another, which is latency. With the technology advancements, videos and images are having higher and higher resolutions, and the file sizes are becoming bigger and bigger. With the traditional cloud computing infrastructure, we are not able to receive results or responses in a timely manner, and that is why edge computing is introduced. Here we go. Edge is basically the layer between cloud and end devices. As edge is much closer to the end devices, we are able to minimize the latency. With edge being added in the infrastructure, we are able to achieve higher performance and lower latency. With this low latency support, we are able to achieve real-time analytics in the end device. We'll be able to respond on the fly. As edge is much closer to the end devices and typically a private environment, it can dramatically reduce data hosting costs by avoiding sending huge amount of data back and forth between the end devices and the cloud. It is also much more secure without needing to worry about cloud security risk. On the other hand, the silicon chips on the edge devices have been in a big revolution in recent years. Now, the processors in the edge devices can handle heavy AI workloads with very low power consumption requirements. The high-performance edge computing hardware makes deploying AI software at the edge realistic. This slide shows the trend of moving from cloud to edge more visually. On the left-hand side, the chart shows the global revenue generated by Edge AI inference chipset will keep increasing in coming years. The revenue could reach over $7 billion by 2024. The chart on the right-hand side shows the transition of more and more AI-enabled devices are adopted at the edge on the devices. The AI applications deployed on the cloud has been decreasing at the same time. This trend will continue to happen. Deploying AI software at the edge is now easy actually, especially from computer hardware perspective. Normally, a computer or a server should be sitting in an indoor environment with stable humidity and temperature conditions. However, the Edge AI devices do not have this luxury. They are usually deployed in outdoor environments, sometimes in even harsh extreme environments like construction sites or oil fields. It is a big challenge for hardware providers to make their products to be able to survive in some bad weather conditions, such as rainy, snowy, extremely hot or cold temperatures. Dust is also a threat to the safety of the edge device. It could cause shorts in the electrical circuits if dust contact the components on the circuit. The thermal condition of the device will be affected too. The dust will reduce the efficiency of removing the heat from the system. Therefore, IP code is created to measure how good a device can survive in harsh environments. For example, sometimes we hear a device is IP65 or IP67 compliant. The first digit defines the level of solid particle protection, and the second digit defines the level of liquid ingress protection. Power consumption is another concern when deploying devices at the edge. There is no AC power sources at the edge at most of the times, so DC power source will be the only option. The voltages of DC power source are relatively low if we compare it with AC power. For AC power, the voltages could be 110 volt or 220 volt, while the DC power only has 36 volt or 24 volt or even lower. So a system with high power consumption is not able to be powered by DC power at the edge, as the current will be high and the system will fail. Low system power consumption is a must. Thanks to NVIDIA, the JSON system on module platforms have very low power consumption that we, Advantech, as a hardware provider, can build AI edge devices with low power consumptions that can survive in outdoor environments and come with high performance at the same time. I will go through more details on Advantech product offerings in another slide. Next slide, Sudi from Radus software will give you an introduction of Cobra Vision software.
Thanks, Nick. Hi, I am Sudi Sankavaram. I am a partner at Radus Software LLC. We are a provider of management consulting and cutting-edge software solutions. We are also the developers of Cobra Vision. Cobra Vision is the only AI modeling framework built from the ground up to serve the needs of the utility industry. Cobra Vision uses Google's TensorFlow as its engine for deep learning and offers various libraries specifically built for the needs of the utility industry. Cobra Vision is optimized to work with the NVIDIA chipset and heavily uses the CUDA parallel computing platform and programming model developed by NVIDIA for general computing on graphical processing units or GPUs. This dramatically speeds up computing applications by harnessing the power of GPUs. Our framework is built on a scalable Python-based interface providing for easy programming and has a strong utility industry flavor. Our current use cases include several that are critical to the utility industry. Just to name a few, we have utility construction site safety detection. This includes detection of hard hats, vests, social distancing, masking, etc. We also have models for pole rot identification and models for distribution and transmission inspections of broken insulators, missing raptor protection, slipping bolts. We have inspection models for vegetation. We have lattice tower damage evaluation and many more. As you could see, most of these models specifically serve the utility industry. On this slide, I am going to bring to light two sets of models that we have developed. The first being those that provide near real-time insight into safety violations. According to OSHA, the leading causes of private sector death were falls, followed by struck by an object, electrocution, and caught in between. Using real-time cameras and drones, Everything on the job site is analyzed by Cobra Vision, whether it's a lack of hard hats, missing vests, or even social distancing. Our software, working with Oracle's powerful construction and engineering applications, give managers near real-time insights into the site activity and identifies anything that's a safety violation. It also allows them to take immediate action, improving job site safety. The second use case is that of predictive AI. Woodpeckers, especially in the middle of the country and to the southeast, cause severe damages to wood utility poles. This results in significant annual economic losses to utility companies. Our solution classifies, contextualizes, and pinpoints potential failure of utility poles due to woodpecker damage using a combination of drone from LiDAR images and Cobra Vision, our AI platform. The robust Cobra Vision framework is built for flexibility and scalability. For safety inspections, the availability of internet was not an immediate, and there was latency variability depending on the location of the utility site, which is why for these models we routed them through a reliable edge computing device from Advantech, which was running Cobra Vision AI models. For the LiDAR-based datasets, the sheer size of the datasets coupled with the lack of need for real-time solution meant that we tweaked the architecture to take advantage of the NVIDIA GPU-based servers on the highly scalable Oracle Cloud. These examples clearly highlight the adaptive nature of Cobra Vision framework and its ability to scale.
Thank you, Sudi. In this slide, I will introduce the Advantech Edge AI computing systems. All of these edge computers you see are built based on NVIDIA JSON platforms. JSON modules are designed following system-on-module concept. There are ARM processors with memory, storage, and GPU processors on the module at the same time. So each JSON module is an individual system itself. It supports Linux OS, and users can deploy AI software under the OS. All JSON modules have some advantages in common, which are low power consumption and high performance when running AI workloads. These advantages are very helpful when they are deployed at the edge. JSON has different flavors, and we have designed different products around JSON modules. The three edge computers in the middle, actually there are 4 different modules, are built based on JSON Nano, Xavier NX, TX2, and AGX Xavier. They all have fanless design, which means more stable in outdoor environment, because fan is one of the parts which will fail in the field very commonly. They all support DC power input with various voltages, and most of them have wide temperature support from -10 to 60 degrees Celsius. The 2 boxes on the sides are network video recorders, also built based on JSON. 3 flavors with JSON Nano, JSON NX, Xavier NX, and AGX Xavier, respectively. Each of them supports 8 PoE cameras and 2 3.5-inch hard drives. These 3 models are designed for video surveillance applications enabled by AI vision. One last product I want to introduce is MIC 715NX, which is an ultimate rugged AI edge system with IP67 compliance, -25 to 60 degrees Celsius wide temperature support, M12 level connectors for most of the IOs, and reserve space for LTE, 5G, or Wi-Fi Bluetooth modules for wireless connections. This product can be deployed in extreme environment and is selected to be used in the solutions that Oracle puts together. Next, Jeff from Oracle will give you an overview of this total solution.
Hi, my name is Jeff Melrose, and I'm the Consulting Sales Director for Oracle's Construction and Engineering Global Business Unit, speaking to the overall Oracle solution. For utility site safety inspections, we initially used construction-based, trailer-mounted camera sets that fed data into NVIDIA-based GPU servers on the Oracle Cloud for processing. However, we soon discovered remote sites were subject to connectivity issues and in some cases, large amounts of data being intensively generated at the edge of the network. Transferring high volumes of data to the distant cloud for processing burdened the network and led to response time and latency issues for the security models, not to mention the high cost of transferring large amount of data over a wireless network. This is where we re-architected our approach for certain models to incorporate edge computing into our solution. After consultations with NVIDIA, they recommended we work with Advantech to identify a reliable edge computing device. Advantech's edge devices allowed for data analytics to be done at the edge of the network with benefits such as gathering more client-side information, shortening the response times, saving network bandwidth, lowering the peak workload to the cloud, and so on. With this revised architecture, we used edge devices to do triage analytics at or near data generation points. The triaged and filtered subset of data was then transferred from edge device to the Oracle Cloud for more detailed analysis. Once the analysis was done using Cobra Vision AI models on the edge devices, any identified events were passed on to the massively efficient Oracle Construction and Engineering applications like Oracle Unifier via Oracle's Project Integration Framework. All notifications were generated and sent out to the right people using Oracle Unifier, and the data has been made available for reporting purposes within the Project Integration Framework database.
Outdoor edge-based AI implementations include a broad range of different technology components. However, we endeavor to simplify our solution in order to automate safety and equipment inspections and deliver triggered events into an easily consumable and actionable format. Our customers log into the Oracle Cloud, specifically to our Unifier application, in order to check on new or existing events, as well as groups of events that can be organized into specific portfolios. The Unifier application is ultimately using data that has been identified in the Cobra Vision AI models and routed into Unifier via Oracle's Project Integration Framework. The events identified by the Cobra Vision AI models are sourced from cameras on a particular job site or by drones capable of scanning assets with LiDAR. These images are then routed through the edge device where embedded Cobra Vision AI models find events that violate safety or asset management inspection protocols. Key takeaway number one so far is to choose experience. Deploying AI in outdoor environments is not easy. Leave it to the outdoor edge AI experts. Advantech, Radus, and Oracle bring best-of-breed skills to all aspects of the solution. Key takeaway number two is end-user satisfaction is vital. Users need to access information on a secure cloud using applications that automate their business processes. AI that works for the business user is key. Key takeaway number three, scalable and versatile AI. All models will need to be adjusted for various use cases on multiple platforms, such as edge devices, drones, etc. And key takeaway number four, make safety and reliability a priority. Initiatives designed to improve safety and reliability are oftentimes deemed too expensive. Using AI to assist with the inspections necessary to improve safety and reliability provide real return on investment.
Thanks to Sudi from Radus and Jeff from Oracle for the insight and information of the outdoor Edge AI vision solution. Thank you everyone for attending this webinar. If you have questions or interests in this Edge AI solution, please send your inquiry to skyserver@advantech.com. We will be more than happy to assist with your inquiry. Goodbye.